Hello, today I'll be presenting about Pichi, which is this small tool I've been working on for some time now, and it's a new way to write applications for Linux. So let me start with the introductions. Who am I? My name is Angelo Verlain Shema, also known as Vixalien on the internet, and I'm a university student. I'm currently in my final year. I'm doing software engineering. And I've also been Google Summer of Code in 2023 and currently in 2026. For 2023, in Google Summer of Code, I was working on the Workbench application, which is a place where you can write applications and test them before you implement them, their user interface, actually. And in 2026, I'm working on adding debug adapter protocol support to GNOME JavaScript. So I'm a very GNOME JavaScript person, at least I'm trying to be. I'm also the maintainer of Decibels and Sticky Notes. So Decibels is also known as Audio Player, and it's this application right here. And it's also the default audio player in GNOME, in Ubuntu, and in Fedora, I believe. And I'm also the maintainer of Sticky Notes, which is this application you can find on FlatHub. You can use it to write notes that stick. In a few words, Pichi is just a framework for writing native GTK for applications, and you write the application using React, which is a web framework that we use to a web library actually that we use to write reactive applications on the web. If you come from web development, you might be quite familiar with React already. And the applications you write will be written in JavaScript, so they will need the GNOME JavaScript engine, or GJS for short, to run them. And you render real widgets, real GTK widgets, and we don't use a web view such as other technologies like Electron or Tori do. So why did I build Pichi? So when I got started writing GTK applications or native applications for Linux, I found that there was some high friction. Especially when starting a project, you will need a few boilerplate code files before even getting started. In the case of Vala, you probably need a source file. You also need to configure Meson so that it can build using the Vala compiler. You can build with the relevant libraries and link with them. And I believe the story is also similar for C and maybe even Rust, although I haven't tried it in depth. And GNOME JavaScript or GJS is already proven in GNOME because it's what's used already for the GNOME shell and a few applications such as Decibels, Sticky Notes that I mentioned, and also a few other GNOME applications are written in JavaScript already. So I feel like we could implement the experience while also using JavaScript. Yeah, so there's probably millions of web developers, and since there's quite a large number of web developers, there have been some tools that have been built by and for web development that improve the experience for web development. So, for example, you have new bundlers that will bundle your JavaScript code into maybe a single file so that it can be distributed and minify it. We have hot module reload or HMR, and we have TypeScript already. So since these tools have been implemented to ease the development of web development, which uses JavaScript, I believe we could also bring those improvements to native application development using GJS and GTK. So here is an example of an application written in with Pichi. So Pichi is just a framework, so we are reusing Adwaita and GTK library, GTK widgets. And here we're also using useState to track application state. This is from React, but these widgets like Adwaita, toolbar view, header bar, and GTK box, button, label, and button are from GTK itself. So these are toolkit widgets that we get from GTK, and we can combine them with React functions such as useState. So here we have, of course, an obligatory counter demo, and you can see it counting from 0 to like incrementing and decrementing, and the state is managed well. So Pichi itself is built as a monorepo because I wanted it to be composed of different parts that can be split and used together if needed. So we have different packages, which I will explain later in the coming slides. But we have packages for Pichi core, which include the application runner, the development server, the compiler that will compile our application into a single file that can be run by GJS. We have a different package for React, which will tell React how to update our or build the application given a widget tree. We also have a package for hooks, which I will explain later. I have also polyfills and a create package that allows to scaffold applications, pitch applications quickly. You also have a few different plugins. We have plugins for React, CSS, resources, and runner, which I will hopefully get a chance to explain later in the slides. And of course, there's also a few examples which I'll be explaining in the slides as we go on. So I tried to split the presentation into different sections. So the first section is titled for web developers, and it explains how Pichi brings the web development process that they know and love into native application development for Linux. Firstly, when you write an application with Pichi, you get support for JSX. So JSX is this syntax where you can use XML-like structures to write your widget tree. So here you can see, for example, how I wrote a widget tree for a toolbar view with a header bar and a GTK box. So this is the syntax that allows you to write it. It's called JSX. So at the end, when we compile this application, it will be written into normal JavaScript. So this acts like syntactic sugar so that you can write your user interfaces faster. JSX has been popularized by React, but it's also used by other toolkits, I believe Solid and more. It's also reactive in that when you write a variable, let's say you have this variable called name, and we set a property on, we have this GTK label, and we are displaying the current name. It's reactive in that if you change the variable up top, this label will also change reactively. And you don't need to write your builder XML like before, where you had to write. I think GTK developers are already familiar with builder XML. It's when you write a different XML file to define your UI and then maybe later link it and bind it to your datas. So here it's all reactive and in one file, which is, at least in my eyes, a good thing because all the code is in one place. And with Pichi, it's quite easy to scaffold an application to get started. If you have Node.js installed, Node.js comes with npm. With a tool, it's the Node package manager. So you can run this script on your local machine, npm create Pichi at latest, and it will ask you for the name of your project and bootstrap it in under 30 seconds. So when you have your application bootstrapped, you can we can start coding. And the very first thing we improve in the developer experience is hot module reload, which is quite familiar to web developers. Hot module reload refers to the way when you write code and save, the UI will update automatically without losing the state. So this happens most of the time. When you update any variable or any label, it will update the UI automatically as soon as you save. But sometimes when you maybe update some state or other things, it may require full restart. But I'm still working on ways where I can reduce the need for full restarts, and it's always going to be hot reload most of the times. Another important feature we have, which is borrowed from web development, is styling, especially CSS modules. CSS modules is this nice way where you have a file with a .module.css extension, and when you have that file with some styles inside, you can import that file as a normal JavaScript module. And Pichi, when it's on the bundling step, it will compile the CSS file and minify it. It will also bundle it automatically without you needing to put it in a resource file, and you can use the styles from it by just typing styles from the important CSS file and then dot the class name that you want to use. This is also nice since it will always generate unique style classes, so you don't also have collisions. So here's an example of a button of a page that was written with CSS modules. Another feature that will be beneficial to React to web developers is the use of NPM libraries. When you write your application using Pichi, you are able to access quite a large number of libraries from NPM. Here I have this example which shows different toggles at the top and also shows a list of blog posts by the authors. You are able to filter the posts by author by clicking on the author that you need, and that will only fetch the specified user's posts. Here in this example, I didn't want to implement everything from scratch, so I used SWR, which is quite a popular library for fetching data, and also it will also reload the data when the user refocuses the application on when the user loses internet and regains internet. So that's one thing I don't need to re-implement because it's already implemented by a package on npm which I can reuse. I also have access to different state management libraries such as nanostores, Zustand, and more. So I don't need to re-implement state management manually as well. Pichi also supports asset bundling quite easily and fast. So here I had this GNOME logo and I wanted to display it in my application. With the old way, or with what GTK developers are familiar with, I might need to write an XML GResource file and compile it and make sure it's in the right place. But with Pichi, it's all automatic. All I need to do is import the file as if it was normal JavaScript code and then use it as a GResource. Pichi will automatically build and bundle and put it in the right place for you automatically so that you can focus on writing the code and less about compiling and setting up your build system. So yes, the next section is titled for GTK developers and also tells them how writing application might be better than what they're used to currently, or even tell them how they can reuse what they have been using to write GTK applications but with Pichi. So yeah, the good improvement in Pichi over writing normal GGS code is that you get access to TypeScript out of the box. It's automatically configured for you. You don't need to install anything. And as soon as you start writing your code with your editor, it will give you IntelliSense and autocomplete your variables before you even complete them. So you can even look up the implementation. If you get stuck, maybe check out the correct property name and so on. And you also have type checking with TypeScript before you compile your code so that you catch errors at compile time instead of on runtime. Yes, and then you also get access to React. React is a library that we use under the hood for writing UIs, and is the same React that has been powering web applications for a long time and is already loved by web developers. So React is probably used in more than 30% of all websites, and it has some nice features such as providers for state management. Suspense is where you can load data while also showing different data when the data is loading, or show a different UI when an error has happened automatically. You also have access to portals for rendering outside the widget tree. Let's say you want to maybe display a popover, you can use portals for that. You also have access to concurrent rendering. React is very fast and is very mature. And when you use JSX and variable updates, it doesn't rebuild the entire widget tree. Instead, it patches the widget that needs to be updated with the correct data automatically. So it's concurrent and it's fast. You also have access to different React hooks such as useState, useEffect, and useContext. And of course, you have access to a plethora of libraries that were designed to work with React, such as ones I mentioned before, like SWR, or even React Query, and much more. So React is a big enough topic on itself, but I hope it can be interesting and of use to us developers. Another thing is Pichi provides different hooks to you automatic for free, which you can use to do most of operations that you do in application. So for example, you have a hook to check the accent color, to check the dark mode, to use a setting. For example, you can use this use setting hook to check for the user's background, or even check if they have dynamic workspaces enabled. We also have a hook for network monitoring, checking if the user is currently connected, and use binding to check the value of a property. And of course, all these hooks will always return updated data. So if the user switches on dark mode and switches it off, it will re-render the application transparently. And also, it allows you to change the different settings. So you can also set dark mode to enabled or disable it, or change the accent color, or change the setting. Yes, with Pichi, you also have access to all the different GObject introspection libraries that we know and love. So the basic ones are, of course, GTK4 and libadwaita. So you have access to the different widgets, adaptive layouts, style classes, and much more. You also have access to glib and GIO for GObject, for lists, for other infrastructure as well. And you have access to also a different old sets of libraries which you can use in your application to get started quickly without re-implementing everything. So with Pichi, you have access to both GObject introspection libraries and also NPM libraries to get you started faster. And another advantage of Pichi is that you can scale your application without compromising performance. Here I have an example of a contact list application. It's written in Pichi, and I used a library called Faker.js to generate 500 contacts, and I display them in a list here using GIO list model and GTK list view. And it's all implemented nicely and it's fast, which might not be the case if you use a web view. Sorry for the quality of this video. I recorded in GIFs, so that's why the quality is lacking. And yeah, when you implement your application using Pichi, you get performance similar to GTK, although there's an asterisk here because there is little overhead from GJS and from React, but it should be negligible. Another use case for Pichi would be nice and easy D-Bus. So D-Bus is this way of it's a way where applications can communicate with other applications or other system components. So one of the different interfaces specified by D-Bus is MPRIS or MPRIS, I believe it stands for multimedia something. I don't remember the rest. But it essentially allows you, when you are playing a video or an audio, to show controls in, for example, the GNOME Shell or the KDE, so that the user can pause and play using the the shell's UI, or maybe even the media keys on their headphones, on their laptop, or their keyboard. So with Pichi, it's very nice and easy to implement using this third-party package called GNOME. While when if you had implemented this manually, it would have been a headache. I'm sure GTK developers in the room have already probably know how hard it is to implement D-Bus. It requires a lot of boilerplate. So yeah, the last section is for contributors or people who want to build with Pichi generally or want to improve Pichi itself. So Pichi is not implemented as everything in one place, but instead it reuses components and libraries from other places as well. So I believe it was worth a mention to mention them. Firstly, we have Jirgen, which is this nice tool by Elul. I'm not sure how to pronounce their name, but they're a helpful person in the community. So this library will use the GObject introspection files. I think it's GIRs, to generate TypeScript code that we can use for type generation and type checking in Pichi. So that's what we rely on for TypeScript conformance. We can also use GNOME as a convenience library for GJS. It provides you access to GObject decorator, so that you can register objects in GObject easily. And also the previous D-Bus example, it was made possible by this GNOME library. And so there's so much more we can do with GNOME. It also gives you a polyfill to fetch, and also access to a settings, a way where you can store your application settings easily. We also use npm and Node.js for distribution. That's how we distribute Pichi, and also allow you to use different packages from npm. We use rolldown for compiling our application and bundling it. So that's where we compile the JSX into normal JavaScript code that GJS can understand, and also all the different features such as decorators, which GJS might not understand yet. We also use tsdown for its CSS bundling functionality, so that's what we use for CSS module support. We also use TSC, or the TypeScript compiler, to compile our code from TypeScript to JavaScript, and also check for errors. Pichi itself also uses oxlint and oxformat for linting and formatting, and change sets for when we want to release a feature, and write change logs automatically. So there's quite a few features on the roadmap already. The most important one, in my eyes at least, is get text translation support, so that you can write your application and also make it so it can be translated into multiple languages. Another feature on the roadmap is multi-platform builds, which we might be able to do and support Windows and macOS builds, and maybe even Android in the future, who knows. Another feature that would be nice is automatic Flatpak packaging. So you write a pitch application and it compiles into a Flatpak automatically. And we might also in the future support other UI frameworks such as Felt, Solid, and Vue, depending on their complexity. Also, if you have a different idea you want to be implemented, of course, it can be put on the roadmap. So thank you. This has been Pichi. I hope you enjoyed the presentation, and if you have any feedback, please reach out. There's a metrics link here, which can reach out to me. It's a group where we can discuss about Pichi and other TypeScript and JavaScript in GNOME discussions. I also have links for the examples that I used in this presentation, and a link to Pichi's source code itself. Thank you.